First, a quick explanation how OpenTracing works. Every component is embedded with the tracer, either at build time or through instrumentation. This will work for microservices architectures as well as for older designs like SOA and other multi-tier apps. Support is available for Java, Golang, Node.js, and almost any other commonly used languages. When a transaction starts, in this case an AJAX call from a browser, the tracer injects trace ID and span ID to the HTTP header. The next tracer extracts the IDs and injects the same trace ID and new span ID to the downstream call, and so forth. Once the last step in the transaction returns, in this case the call to the database, the tracer sends the data to the APM service. The data includes the trace and the span IDs, duration of the operation, and other attributes including the service and operation name, SQL tags, and IDs, and more details that describe the specific operation. When each method returns, the tracer on that component will send a similar span with relevant details about the specific operation that was just completed. Eventually, the first call will return and the root span will be sent, completing the trace. The Trace Explorer page is used to find, group, sort, and view traces and spans. It uses a simple but powerful query language. At the top of the page are a few quick picks. This provides some of the more likely searches a user will be interested in. However, users can write their own queries using the quick picks as examples. To demonstrate this, let's see how a user will check that the service is load balanced correctly. Let's check the front store service. I will group the service spans by the app server name. For convenience, instead of providing an aggregation function to each of the attributes already in this query, I'll replace them with a star. I see that the service is balanced load-wise, but it seems that the average response time is about 20% slower on one of the app servers. I will expand the query to break down the load by the operations. The only significant difference is with the order confirmed operation. When looking at the instances, some are significantly slower, but they are executed only on that one app server. Comparing few of the traces, it is obvious that an additional functionality, the call to the add service, is what's slowing down these operations. Checking the attributes of spans running on the slower app server, I can see that the add service feature flag is enabled on it. This is a canary testing enabled randomly, proving to be too slow for full deployment.